All right, this is your last video for AP Chemistry. So this is the last day of new lessons. We're going to finish up Chapter 18. The middle parts of Chapter 18 are no longer in the AP curriculum, so we're just going to jump right to the end of it, Section 18.7. And this talks about electrolysis, which we talked about before. And there's two different ways to do this. There is a galvanic cell, which is when the reaction is spontaneous and it produces electrical energy. And then there's the electrolytic cell, which uses electrical energy to make a chemical reaction happen that was not spontaneous. So just keep in mind those are the two different kinds of cells that you can use for electrolysis. We already talked about a lot of that, so I'm just going to skip down here to the electroplating part. This is just when you deposit neutral metal atoms on the electrode by reducing the metal ions in solution. So notice that in this picture that silver ions are being both reduced and oxidized. So there's some here coming off to form Ag+, and then over here you're plating the Ag back onto the cathode over here. You can talk about electrolysis of water. You hear that quite often, and this is the process where you break apart water into hydrogen gas and oxygen gas, but you do have to use electricity to do that. So it's a pretty high activation energy, which is why water doesn't naturally just break apart. It naturally goes together, but you can force it to break apart using electrolysis. And notice that notice that there's twice as much H2 gas as oxygen gas because of this 2-to-1 ratio here. When there's a mixture of ions, the one that's most easily reduced, which would be the highest value, positive values of E cell. So the more positive one will be plated first if it's a competition. So if they ever give you some and ask you which one will be plated first, you're looking for the higher value of the E cell. And then this is going to walk you through all the different steps for doing one of these big fences, but I'm just going to work through one of these for you, and I think it'll make more sense. And before I do this, these are just some real-world applications of this. Notice again here, the more positive reduction will plate first, and this right here is going to help you a lot. So we already talked about a volt is a joule per coulomb, and if you can also remember that an amp or an ampere is equal to a coulomb per second, that's the unit for that. Those two conversions right here, these are going to help you so much in these problems that I'm getting ready to show you. They're basically just really big, long fences. So you just have to keep working on those units until you get the units to be what you want it to be. So this question is saying, how long will it take to produce 10 grams? We're going to start with 10 grams of bismuth by electrolysis. And we've got a current of 25 amps. So let's go ahead and start with what we're given. We have 10 grams. And this is going to be a big, long fence. The first thing is whenever you have grams, you're almost always going to turn it into moles. So let's go ahead and use the periodic table. If you find bismuth, it's about 209 grams per mole. And eventually we need to get to amps, and amps has coulombs, and another relationship with coulombs is if you can use Faraday's constant. So just as a reminder, Faraday's constant is 96,485 coulombs per mole of electron. So we can't really get this to coulombs yet because we don't have moles of electrons. Right now on our fence we have moles of bismuth. So the next thing we want to do is to convert it from moles of Bi to moles of electrons. So for every 1 mole of bismuth, it's going from Bi neutral to whatever the charge is in this compound. So now we need to figure out what the charge on bismuth is in that compound. So oxygen is -2. And the whole thing needs to add up to +1, and so bismuth has to be +3, because +3 and -2 would give you an overall charge of +1. So we're going from neutral bismuth, remember this has a neutral charge, to +3, which is a difference of 3 electrons. And so now I know that we have 3 moles of electron for every 1 mole of Bi. Now we can use Faraday's constant. Okay, so if we stopped here, we would have coulombs. We don't want coulombs, so we're going to keep on going. And we do have amps though, and notice that coulombs are in amps. So an amp is a coulomb per second, so we're going to flip that upside down so that it's seconds per coulomb. So this says we have 25 amps, which means we have 25 coulombs per 1 second. So we need to flip it because we need coulombs to be on the bottom. And now if we check our units, so we have grams cancels grams, moles of bismuth, moles of electrons, coulombs, and we're left with seconds, which is a unit of time. And now you just punch it all in your calculator. So for these problems, when you notice that you have volts or amps or something, and especially if they give you masses, just recognize that it's going to be a big fence. You're going to need to figure out the moles of electrons from the element to the compound to see what the change in the charge is there. And then what I have here in the two red boxes, that's going to help you out so much. If you can remember that a volt is a joule per coulomb and an amp is a coulomb per second. And then you just arrange it, watch out for those units, and type it in your calculator. And that's it for chapter 18, and that is actually the last new lesson for chapters for me. We're going to do another whole section on spectroscopy in our next section, but this is the last textbook chapter for me. Congratulations.